vectors. With respect to the origin O, point A has position vector given by 1, 5, 6. For the line L, 4, 1, 4, 0, 1 plus lambda times minus 1, 2, 3. Find the acute angle between the directions OA and L. So we have this vector formula in MF19, the only vector formula. This is the dot product. So if you rearrange this, so you divide both sides by magnitude of A, magnitude of B, we have this form. So this is the form we're going to use. A dot B divided by the magnitude of A times magnitude of B. So for the A dot B, for the vectors A and B, we use the OA, which is 1, 5, 6, that's the OA. And for the line direction of L, that is the minus 1, 2, 3. So that's the vector A, vector B, vector A dot vector B divided by the magnitude of. To do the dot product, if you look at this formula, we just multiply corresponding components, x with x, y with y, and so on. So for the dot product, we do 1 times minus 1, which is minus 1, 5 times 2, which is 10, 6 times 3, which is 18. Now for the magnitudes, there's no formula in MF19 about this. We have to use the square root of 1 squared, 5 squared, 6 squared, add everything. So this is the magnitude of this guy, and same thing, this is the magnitude of this guy. And then just use a calculator. We're gonna get 27 over this in a simpler form. Since we are looking for theta, remember this is still cos theta, this is not theta. So if you're looking for cos theta, we get this inverse cos this guy, we get the angle in the first quadrant in this case. So since we are looking for the acute angle, sometimes when we do this, we get something in the second quadrant because the numerator is negative. So if that happens, you can just ignore the negative sign and you will get the first quadrant value, or you can just do 180 minus to get the first quadrant acute angle. Find the position vector of the photoperpendicular. So just start by drawing some diagram to visualize things. So let's say this is the line L with this vector equation, and this is the point A, and this is the foot of perpendicular from A to the line L. So we don't know the coordinates of P, you can just call it x, y, z, but keep in mind that since P is on this red line, we can always replace the x with 4 minus lambda, we can replace the y with 0 plus 2 lambda, and the z with 1 plus 3 lambda. Okay, we can replace them if we want. Now we use the fact that since it's perpendicular, this direction dot this direction equals 0. So perpendicular means dot product equals 0. So for the AP, the vector AP is the coordinates of P minus the coordinates of A. So the vector AP is x minus 1, y minus 5, z minus 6. This is the vector AP. For the L direction, we use this vector. Remember, this is just a random point on the line. This is the direction of the line. So we use the direction vector and we use the dot product now. So minus 1 times x minus 1, 2 times y minus 5, 3 times z minus 6. So remember, we can replace this x with 4 minus lambda and so on. So we replace the x with 4 minus lambda, the y with 0 plus 2 lambda, and the z with 1 plus 3 lambda. So we can simplify a little here. We have minus lambda, that's plus lambda. We have minus 4 minus 1, so minus 3. And we have 2 times 0 is 0, 2 times 2 lambda, 4 lambda, 2 times minus 5 is minus 10. And here we have 3 times 3 lambda, 9 lambda. And 1 minus 6 is 5, so 3 times minus 5 is minus 15. And we can simplify 1 plus 4 plus 9, that is 14. And minus 3 minus 10 minus 15, that will be minus 28. Bring it to the side, to the right, we get plus 28, and we divide both sides by 14, we get the lambda. So to find the coordinates of P, to xyz, we can just replace the lambda with -2. So replace the lambda with -2 and we get the position factor of the foot of perpendicular, which is 4 minus 2 is 2, 0 plus 4 is 4, 1 plus 6 is 7. So that's the final answer. Hence, find the position factor of the reflection of A in L. So previously, we have the P already, which is 2, 4, 7. We need to find the reflection of this point in this line. So this is the mirror, this is the object, and we're finding the image, which is supposed to be around here. So it's supposed to be around here. So to make things simpler, I usually use this kind of diagram. So just make it a straight horizontal line. We have point A, we have the mirror, and we have the image we are looking for. So just look at the pattern. As you go from A to P, what is the pattern? What is the factor AP? So from 1 to 2, that's going to be +1. From 5 to 4, that's going to be -1. From 6 to 7, that's going to be +1. Okay, this is actually the factor AP. Or you can just subtract 2 minus 1, 4 minus 5, 7 minus 6. Okay, so this is the factor AP. So the process should be exactly the same from P to A. So also +1 minus 1 plus 1, which means 2 plus 1 is 3, 4 minus 1 is 3, and 7 plus 1 is 8. So just like that, we have the image is 3, 3, 8. Alright, I'll see you